Hi everyone, welcome to the demo video for Lobaki's IFX content library. IFX are the objects that we can load directly into our scenes, our classrooms, our lessons, etc., and use them as manipulable objects or teaching tools. And we've got a whole bunch of them that we've made just for you all, so let's go ahead and get started. We'll click on this Start Session button over here on the left. And I want to choose a nice big open space. I like the creator rooms personally. We'll do the one with grass. So I'll click on Just Me, and here we go. All right, here we are. Plenty of nice wide open spaces to work in here. So let's go ahead and launch our menu using the B button on our right controller. And we'll go down to the IFX tab at the bottom. It looks like these three little building blocks. So within our IFX tab, we can go up here to this tab right next to Public. Yours might not say Lobaki. It will probably say the name of the group or organization that you are associated with. But regardless of what it says, this is where all of our custom IFX will show up. All right, so our first few right here are just some Lobaki branded IFX. For example, we've got our Lobaki logo that we can stick in locations and sort of customize things if we want. You might not use those, but feel free if you'd like. After those first few Lobaki themed ones, we've actually got some of our science content here. So we've got an explosion, our Big Bang explosion, a nice big fiery blast. And we paired this with a sound effect in one of our lessons. This is the Big Bang sound effect. It is what scientists estimate, as far as they can guess, how the Big Bang might have actually sounded. And it's kind of surprising. I'll go ahead and delete that and delete our Big Bang explosion here. Moving on, we've got quite a bit more science content here. We've got this that illustrates how different fluids of different densities can actually stack on top of one another. So if you're teaching about mixtures and solutions, stacking oil and water, for example, you might use this as a visual representation to show how these three different fluids coming up from these tanks actually stack on top of one another in layers instead of mixing. I'm going to load a couple real quick here. So these three IFX, liquid particles in tank, gas in tank, and solid particle arrangement, are some animated IFX that show us how the particles of each of the three main phases of matter actually kind of look and work and move around and interact with one another in an enclosed volume. We've got a crystalline structure for our solid right here. Not all solids look like this, but if you compare this solid arrangement with our liquid arrangement, we can see that these particles slip past one another and are a little bit more spread out. And then one step up from that, our gas particles are moving around all over the place, flying right by each other. And so this is a great visualization for the three states of matter. Moving on, I'll go back to our page 2 where we left off. We've got this IFX that illustrates hydrogen and helium atoms forming. So we use this as an illustration to talk about at the beginning of the universe, there were all of these particles kind of just floating around. And they actually started to come together into the arrangements for hydrogen and helium atoms and started making some of these fundamental elements that we know about and observe today. So I'll play that one more time. We'll see these particles come together and they actually snap into their arrangements just like that and then move around. We've got our solar system, IFX, right here. This is a really cool one. It is an animated model of the solar system where all of the rotations and revolutions of the planets are actually to scale with one another. So we can see that all of our inner planets in our inner solar system are orbiting the sun quite quickly compared to some of these outer planets. But eventually these will make their way all the way around the sun, even tiny little Pluto way out here. If I make it nice and big, and we go out to visit Pluto, we can actually barely see it move across the sky. So it is going slowly but surely way out there around the sun. All right, moving on. This IFX illustrates the speed of light. We start off with this little orb of light going around the Earth. And what we want to show here is that the speed of light would actually go around the Earth that fast in real time. It would orbit the Earth 7 times per second. So we start off with just this ball of light going around Earth very slowly, and then we jump to that crazy animation of it making 7 full rotations around the Earth per second to sort of show off how crazy fast the speed of light actually is. It should start back up here in just a second. Crazy fast version. Well, we'll keep going. All right, the next one that we have is this interesting little visualization that shows an approximation for the number of stars that we have in the known universe. So you'll see that this is a map of at least part of the United States here. And all of the states from Virginia all the way up through, close to the boundaries of New England here, kind of up through New York, I guess. If we were to make a pile of sand that covered all of those states, as tall as the Empire State Building, we would actually have close to the number of stars in the known universe as there are grains of sand in that pile. So that's pretty crazy. We've got a volcano. This one's pretty fun. I like taking this to the Pompeii stage location and blowing everybody's mind by having there be a real volcano right in the middle of Pompeii. It'll erupt every few seconds there. We've got this pretty cool swirling galaxy that I can put up in the sky. This looks a lot cooler when I have a night sky to put it in, but this will work for right now. We've got a little animation that shows sort of how the sun came to form. Just a bunch of particles kind of coalescing and forming under their own gravity to come together and form the sun. Moving on, we have just the normal animation of the sun. There we go, I can make that a little bit bigger. So a nice glowing sun orb that spins around. We've got another version of that sand pile visualization, just with a full map of the United States this time. I'll give you a couple options there. We saw our solid particle arrangement already, and our elementary particle swarm, we can pair this with that other IFX that we saw on the other page, the hydrogen and helium formation, and basically just show that initial swarm of those elements coming together while there's still another swarm kind of going on in the background. Moving on, we have this cool particle effect that shows some particles colliding and some sparks flying. Not sure what you'd want to use that for, but it's there if you want it. We also have one more visualization of the number of stars in our universe, and this one is a little bit more math-oriented. It deals with exponents. So right here at the beginning, we can see we've got a block of 64 little spheres. And that represents 64 stars. Now, if we turn that whole block into one of these orange balls, so one of these orange spheres represents that whole block, the next level up we would have basically 64 squared, which is 4,096 stars. Keep on moving up, squaring as we go. And eventually we come to the very end where we see that there are 3.02 times 10 to the 23rd stars in the known universe, which is a mind-blowing number that we can sort of convey with exponents like this. Right here, we have a model of the Earth, except if we go around and look at it from the side, we can actually see that it's a cutaway model. So we can see the different layers of the Earth as we go down to the core, our glowing core. And there's another version of this as well, where there's actually an infographic that we can pop out. And I might have to make this a little bit lower so we can read it. But we can see a description of each of the layers of our Earth and read about them as we look at them in this diagram. Up next, we have a selection of geometric tiles. They're kind of scattered around in here, unfortunately. That's another pentagon tile. There we go. So the cool thing about these tiles is that all of the side lengths should be pretty much the same. So I can actually play with shapes and patterns and tessellations. Make some cool designs here. So we've got all the basic shapes, all the different types of triangles, acute isosceles, equilateral, obtuse isosceles. We've got hexagons, narrow rhombus, the pentagon triangle, regular rhombus, square, trapezoid, wide rhombus, all the different shapes that you can play with here. All right. Now we've got a little bit more science content, specifically focused on stuff that you might find in a science lab. So for example, we've got an Erlenmeyer Flask. And we can see it actually making some reactions there or something like that. If I stick my hand in it, I should be able to toggle that reaction. And I can see those bubbles down inside of it forming and some steam or something coming out the top. And we've got the markings on the side so we can tell how much we have in there. Now we also have this same flask on a Bunsen burner. And instead of toggling that by sticking our hand in there, we can actually turn on the gas on our Bunsen burner just like that. We'll see that flame starting to appear, and sure enough, we've got our chemical reaction coming up right there. So we can turn that back off if we want, and there it goes away. If you want to talk about lab safety, there are some bits and pieces in here that you can use. You can tell students that this is where they would throw away their chemically contaminated broken glass and plastic. I've got it kind of going in the ground right there. So in a bin that might look like that. We've got our lab safety manual, which is a super handy resource to have. Let me spin that around for us here. So our lab safety manual, we can walk on up to this, open it up, and see an illustrated guide of the do's and don'ts of being in a science lab. So we can flip through this. We can learn about different hazards in a lab, stuff that students need to pay attention to, and flip back and forth through our book here. Up next, we have a tape measure. This is actually a fully interactive tape measure, and it is at scale in the scene. So I can click this +1 foot button. Well, it looks like I might have done 2 feet there on accident. But we can measure out, at the appropriate scale, anything in our scene. So I could take this over to my shapes, for example, and see that each side here looks to be about 15 inches. And I can keep expanding this out all the way out to 10 feet. If I just keep holding down that button. And then to reset it, of course, we just pull that little trigger and it zips right back. We also have a metric version of that, and we can measure it in meters as well. So much smaller marks here for the centimeters, but still at the exact scale within the scene. So we could learn, for example, that 15 centimeters is approximately equal to, it looks like, about 15 inches is approximately equal to about 39 centimeters. Moving on, we have our fire extinguisher. This is actually a totally interactive IFX as well. And so we can train people how to use a fire extinguisher in a lab or in other training settings with this tool. And we've got instructions on it as well. Step 1, pull the pin. Step 2, aim at the base of your fire. Step 3, squeeze the lever. And step 4, sweep side to side. Let me get us an actual fire in here that we can fight. That'll be fun. There we go. There's a little campfire for us. You can find that just in the normal public IFX library. But let's fight a fire. Step 1, pull the pin. Step 2, aim it at the base of the fire. And step 3, pull that trigger. Step 4, sweep it side to side. And there we go. Here, let me put out our fire. Hey, we did it. Nice. And we can reset this just by putting that pin right back in. Up next, we have our emergency eye wash, which you might find in a science lab. I can pull on this handle right here and get the shower coming down from above me, or push this button right here and get my emergency eye wash, just like that, or turn those back off. I've got that same Bunsen burner that we saw earlier, just without a beaker. And just like before, I should be able to turn that on or off and get that little flame coming out the top. Up next, we have our science lab fume hood. Place that right there. And I can walk up to this, open the sash, or bring it back down to close it. I can turn on my vent, and that'll turn on the light in there, as well as play a fan sound effect. Turn that back off. Now, within my vent, I can turn on steam, nitrogen gas, our vacuum, a jet of water, or a blast of compressed air over here. It's pretty cool too. If we turn on our nitrogen gas or our steam, and then we turn on our vent hood, we'll see that they actually start to get sucked up into the hood. All right, up next, we've got one of my favorites, our microscope here. This microscope is fully interactive, and we can turn it on or off using that button right there. And we load out this panel of 4 different samples right here. All I have to do is walk up and touch one of these samples, and it'll load in our slides. There we go. So I can see the sample appear on our screen here, or I can bring it down and look at it through the eyepiece right there. And I can go to the different zoom levels and see what it looks like zoomed in. You can see our little lenses spin around there and change our visibility. Let's check out the other samples. Bullfrog blood smear. That's pretty cool. Dust mite aggregate. Little guy way zoomed in there. Or red stem dogwood bark. Tree bark looks super cool under a microscope. All right, that's the microscope. We've got this interactive diagram of the moon phases. So I've got this big moon right here in front of me, and currently we see it set to waxing crescent. If I select first quarter, we'll get that first quarter of the moon lit up. Waxing gibbous, full moon, and then we'll work our way back down. Waning gibbous, third quarter, waxing crescent, and new moon. To go along with our measuring tapes, we have a protractor. You can use this to measure the angles of your shapes as well. So I know that this is an equilateral triangle, and so I know that this angle right there should be 60 degrees on this triangle, And sure enough, there it is. This is an octagon, so I should see 135 degrees between our edges there, and sure enough, I do. So this is a great little tool to go along with our other geometry, shapes, and measuring tools. We've got a couple little products that we made for FedEx, along with some conference cameras that we made for them. These are some fun little cameras that you can stick around in any of your locations if you wanted to. Up next, we have the International Space Station, which is a super cool model. We can look at all the different little details on this thing, all of the trusses and parts and pieces of this thing. It's quite something. And of course, we could send it way up into the sky. There we go. All right, now we're going to move into some of our chemistry content. We've got some models that talk about chemical bonding, both ionic and covalent bonds. So this is actually a water molecule, and this is what the covalent bond of H2O looks like. And what's really cool about this model is this is actually how those bonds would look using the hybridized covalent shells. And those are really hard to visualize. They've got some funky shapes and some weird angles. But we actually show that visualization with all the right angles and all the right shapes. And you can see all the electrons in the different parts of the shell. You can even stick your head inside and look at the oxygen atom here in the middle and count the number of protons and neutrons within the nucleus. We've got some content that talks about ionic bonding as well. So here is sodium fluoride, for example. And there's an animation that plays. Our sodium atom comes over and transfers one of its electrons over to our fluorine atom. And we see that those charges actually change. We get a cation and an anion as we make sodium fluoride. And we can pause this as well and take a look at the animation as it happens, or just pause it on that bonded form right there and observe our sodium fluoride. Similarly, we've got magnesium sulfate. Here's our magnesium atom that comes over and transfers two of its electrons over to this sulfate group. The sulfate group is covalently bonded, and so it's looking for two electrons to be transferred over to satisfy two of its oxygens here. And so just like before, we see that animation and we can play or pause that at any point. We've got a couple more of the ionic bonds. Here's sodium chloride, table salt, and NaOH. Sodium hydroxide. All right, let me clear these out real quick. We've got some more covalent bonding visualizations. Here is O2, and we can see the pi and delta bonds in the hybridized form here in the O2 molecule, which is pretty cool. Here's also just a more simplified model of covalent bonding with H2, just two atoms of hydrogen sharing their electrons there. The really crazy one is on the last page here, and that is our glucose bond, our glucose molecule. So this is a full molecule of glucose built out using the hybridized structures. So we can see all the crazy different angles that things are forming at. We can see that carbon chain that makes up our glucose molecule and all of the little hydrogens or oxygens stemming off from it. This is really fun to make nice and big and have students explore. And finally, we've got some cool visualizations of magnets. So for example, we can show how you can build solenoids and make electromagnets by adding a current to some coiled wire. And we can see that that electromagnetic field actually gets bigger and stronger the more coils you add. So look at the difference in the field when we have 26 coils versus only 15. We've got this model that shows a visualization of the magnetic field around planet Earth. We've got the magnetic field around a horseshoe magnet. We've got magnets with like poles repelling each other, and magnets with opposite poles attracting each other. We've got a visualization of the electromagnetic field around a single bar magnet, and two fields interacting with each other when we have two bar magnets. And it looks like that completes our library. We are always updating our library, so please keep checking back for more content.